So today we'll be talking about thinking and braking distances.
Okay, sir.
This one. Thinking and braking distance is important because this is equals to the total stopping distance of any individual that is driving a car or any vehicle. So the total distance traveled during the time it takes for a car to stop in response to some emergency. Maybe there could be a, let's say you are doing urban driving in near your villa, and then there could be a child on the way. Okay. So you will see the child, you will think to brake, and before that thinking, you will be traveling at that same complete speed that you were traveling. Then after applying brake, your car will come to a stop. That's why it is important that in certain areas where it is sensitive, where it is required that you brake often, you drive at a slower speed so that your thinking distance is not large enough. And since you're driving at a slower speed, your braking distance will automatically be smaller. So thinking plus braking distance is equals to the total stopping distance. So what is the thinking distance? Thinking distance is the distance traveled in the time it takes for the driver to react, or the reaction time, and within that reaction time, how many meters that the driver crosses. Braking distance, it is after applying the brake, due to the conditions of the brake, due to the condition of the tire, due to the condition of the road, all of these matters, the braking distance will vary. The distance traveled under the braking force once the braking force has been applied. Okay. Now stopping distance is equals to sum of the thinking distance and braking distance in meters. So if we add them up together, total, we get the stopping distance. For a given braking force, the greater the speed of the vehicle, the greater the stopping distance. So here is a question. At a speed of 20 meters per second, a particular vehicle had a stopping distance of 40 meters. The car traveled 14 meters whilst the driver was reacting to the incident in front of him. What was the braking distance? So, of course, if, see, at a speed of 20 meters per second, the vehicle had a stopping distance of 40 meters. This includes thinking plus braking. The car traveled 14 meters whilst the driver was reacting to the incident in front of him. So it is his reaction time. We can actually find out his reaction time. How can we do that? Since he is traveling 20 meters per second, 14 divided by 20 meters per second will give us the number of seconds it took for him to react. Can you do the math?
It's 0.7.
0.7.
Yeah.
So 0.7 second it took him before he even could react to the situation to apply the brake. Okay. So what was the braking distance? The braking distance would be from the 40 meters if we take away the 14 meters. Okay. And that would be giving us 26 meters. So after applying the brake, the car took 26 meters to safely come to a stop. Moving on. Estimating the stopping distance of a particular vehicle. For a given braking force, the speed of a vehicle determines the size of the stopping distance. The greater the speed of the vehicle, the larger the stopping distance. This is a usual case scenario. Now you have to understand here, There are also problem like this was an old problem actually. All right. Recently, this problem is minimized as much as possible. This is called skidding. When you apply brake very hard on the wheels, the tires has a tendency to lock up. Okay. Once the tire
Yeah.
locks up, then no longer the braking force is effective so much. I mean, it does brake. Okay. It's not like it's not braking. It's just that when the car tire starts skidding, the driver do not have any control over which direction the car would be moving towards. So the resultant momentum is the decider of the direction. Whichever direction the resultant momentum can act on, in that direction the car will move. Because the first two wheels of the car are more heavier, because they are the one that is carrying the engine, and you are very likely to be sitting in the front, right? Before sitting back.
Yeah.
So what happens is that the center of gravity is nearer to the, even though the weight distribution is very good and all and everything, but during that strenuous situation, the center of gravity is near the front. So the car tend to spin the backside first, because whatever is lighter will spin faster, na? All right, according to moment.
Yeah.
The same force is being applied, but mass behind is less and forward is more. So it is the point of center of gravity, and the car tends to spin backward any direction other than your desired direction. So to stop this, all right, the car's braking system now have what we called a ABS, anti-brake locking system. Okay, so which doesn't allow the tire to fully lock up. If it senses the sensor, if it senses that the car tire is about to lock fully, then it releases the brake only for half a spin or maybe quarter of a spin, depending on the quality of the ABS. All right, and then locks onto the grip for braking the tire again. This gives the driver even ability to maneuver the car while the car is in its full braking force. Okay. So
Yes, sir.
yeah, so now these are the things that we have done to minimize risk. But let's say if there is a oil slick on the road, this cannot be prevented. All right, you get my point. If the road is too slippery, all right, very slippery due to some oil falling on the road and other conditions, then the ABS might work, might not work. Okay, because
Yeah.
ABS works on based on the force acting on the tires, and that usually doesn't change even if there is some oil slick on the, like, the road is quite slicky, so it may get you into a situation where the brakes holds stops, and gets you very nervous as well. Okay, maybe if you have ever where in the car where your dad or your mom was driving, and then they had to brake all of a sudden, the car might
Yeah.
have a vibration while stopping. Okay, then you would know
Yeah.
that ABS system was doing its best to keep the car under control. The biggest problem is the driver used to lose control while pushing the brake, because usually your tendency will be not to hold the brake at, like, you would try to apply your maximum force to hold the tire so that you don't go and bump into something. As long as you don't go and bump into something, you're quite safe, right? So based on that. Okay, now here are some images given along with, if you were traveling at a certain speed, what would be your thinking distance? And then what would be your braking distance? Now, the braking distance, all right, is considered in this way. The average car length is equals to 4 meters. Okay. And, then they basically thought of this particular, by means of experiment, they gave this particular distances that a particular car will travel. Okay. Now, a vehicle stopping's distance increases with speed. A speed of 20 per hour, the stopping distance is 12 meter. Whereas at 60 mile per hour, the stopping distance is 73 meter. Okay. Now, this is the thing. Under what we already discussed that if the road condition was not good, if the braking condition, the brakes are not good, all right, or if there is like sometimes braking system may have air in the system, like some kind of problem is there, then the braking distance will increase. Also, at the same time, if the driver is not under normal circumstances, like sober, okay? If the driver is drunk, then thinking distance will increase, and this will greatly impact the braking distance, because even a drunk driver will brake, okay? Because it is his reflex to do that.
Yeah.
Yeah. But the problem is he will take, instead of, remember the previous person was reacting at a 0.7,
Yeah.
right? Which is 700 millisecond, by the way. You have to multiply
Yeah.
1000. Okay. So within 700 millisecond, he braked. So under normal condition, he will brake at 700 millisecond. Let's say if the person had caffeine in his system, he will brake sooner. Okay. Maybe he will brake at 650 or 600 milliseconds. Okay. But let's say
Yeah.
person has alcohol in the system, then the person will already have a vision problem. Did you get my point? If the
Yeah.
person was like having low sugar, okay, having high sugar, all right, if the blood pressure was too high, all right, all of this is a very typical normal day-to-day situation, by the way, except for the part of being drunk and driving, all right, even that is normal, all right, even that is
Yeah.
at night there are many driver that drives funny, all right, uh
Yeah.
not to mention them anything, they just might be sleepy, okay. So yeah, in Dubai, I think that's also a practice. People do sleep driving, they sleep halfway through, because Al Khail
Yeah.
is straight and Jebel Ali is very straight. I don't know. People just change lane, like 5 lanes, they're going in one direction. All right. They're going in full speed, by the way. Okay. Then they all of a sudden come into sensors and they're like, oh, okay, let me go straight for a few seconds. Maybe the camera,
Yeah.
and sometimes the camera flashes even if you're constantly changing lanes. Those are warning flashes. So here, now you get the point. If the person is under influence, whether that can be some drug, if the person is tired, that can increase their reaction time. They
So
might,
the bigger, so
yes,
the longer the thinking distance, the longer the braking distance.
of course, the overall braking distance will be greatly impacted by thinking distance. Why?
Okay.
Because during thinking distance, you are traveling at that same full speed that you were traveling. 112 kilometer per hour. You traveled at 112 kilometer per hour, and you can already understand traveling for 1 second at that speed would be a quite a big distance. Okay.
Yeah.
Yes. So yes, that's the main challenge that we have. So around 100 kilometer per hour, your car is traveling nearly 30 meters per second. So you will cross 30 meters, all right, within 1 second. Now, why these distances are less? Because these distances, you know, are those standard 0.7 seconds thinking time, okay, or lesser.
Yeah.
So here is the thing. You can see if we show a velocity time graph, all right, then we find out while the driver reacts, the vehicle continues at a constant velocity. This area represents the thinking distance. While the brakes are applied, the vehicle decelerates until it comes to a halt. This area represents the braking distance. When you are fully alert during the thinking process, you may not apply brake. That's very reasonable. If you are in a freeway, you do not worry about going and crashing into someone. You mostly worry about someone coming and crashing into you because people are on the phone, right? They have to,
Yeah.
so they're not looking forward. So if you just brake all of a sudden, so braking is that's why not appreciated in Dubai. Okay, one of the common mistakes that people will do. You see, during even the training, they will ask you, before you apply brake, look behind, which is kind of weird in a sense that you only have to look forward, you know, sensing the danger that is forward, right? But the
Yeah.
problem, the problem will come from backward. Okay. because you going and crashing into something rather be controlled than someone coming and crashing into you full speed. Okay, that's gonna be the biggest issue. So yes, at times you are not even allowed to stop in the red light. Let's say within 0.3 seconds of the blinking, you're not even allowed to stop in the red light. That's because you should you should pass by. All right, because the car behind might crash into you if you stop at that point. Okay. So I think there is a white line if you are crossing that particular red line sign. All right, over
Yeah.
the street signs. Yes, there is a line, and if you cross that within 0.3 seconds of the light going red, then you do not get fined. All right, even if the lighter flashes, it's not a problem. All right, but it has to be
Yeah.
within 0.3 seconds, and there has to be a vehicle behind you. Also, that one thing. All right, you can't accelerate. There are a few rules, by the way. Okay, judgment that you are in a danger, you will not be fined. The fines in the roads are actually just to keep you safe. They are not there to punish you for
Yeah.
uh, just for driving. Okay, like you're driving in Dubai, okay, you need to pay fines so that they can build roads. No, that's not how it works. It's just to keep,
Yeah.
all right. And the fine amount is high because people are rich here. Okay, I've seen people going through four flashes just like that, and then getting stopped by police. Okay, I've seen
Yeah.
they're like just gossiping. They just gossip. Yeah, they didn't notice. All right. So here, while the driver reacts, the time taken to press the brake is called the reaction time. So, I mean, you have drank caffeine or coffee, obviously, and you have found out that even in a very tiring situation, it can energize you up. Okay. So,
Yeah.
caffeine decreases reaction time. Okay. The velocity continues moving at constant speed. By the way, when the person is reaction time is being experienced, the car keeps on moving at a constant velocity. The area underneath the graph during this time represents thinking distance. Okay, that's why you can see the line is straight because you are at constant velocity. Okay,
Yeah.
as soon as the brakes are applied, the vehicle decelerates to a halt. Whenever you are applying braking force, the moment the brakes touches that metal portion to basically brake, it is pure friction. Okay, that part,
Yeah.
pure friction, it is going to generate heat, is going to dissipate that energy, but the brakes being applied also need to work on the tires and the road. So if the tires are worn out, then braking distance will increase. The area underneath the graph, this represents the braking distance. Now here you can see the line is straight, right? That's because this is considered as a uniform deceleration. Okay. So these are the time when you didn't really rush into the brake, but you just went on a uniform deceleration for stopping that particular car. Means you applied the brake softly. Okay.
Yeah.
So here is a graph. You can see the graph. Okay. The first portion is the one that is driver's reaction time. Can you find out how much is the distance the driver is moving? The driver is in the beginning, the driver was moving at 35 meters per second.
Yeah.
Okay. So for 1 second, full 1 second, the driver has the time to react. Meaning the driver took, all right, for the reaction time, the driver took 1 second.
1 second.
The braking distance of the car would be thinking plus braking. So thinking is 1 times 35, so 35 meters. And braking will be, all right. So for the braking, it will be half times the distance between these 3 points is 3 seconds. So half times 3 times 35. Okay.
Sir, isn't it 3.5?
Which one is 3.5? Ah,
The
yes.
braking.
Thank you. Thank you. Yeah. All right. I just didn't take the full time. 3.5. Very good. Okay. 3.5 times 35. Can you give the answer, please?
Uh, 61.25.
Okay. So 61.25. Very good. Okay. So put this together because the car was already traveling at a very high speed, by the way. 35 meters per second is quite a high speed. Okay. So put this together. So 35 plus 61.5. What is the answer?
1 second, sir. It's 96.25.
So yes, 96.25 meters will be needed. The total time will be needed. So yeah, they got similar to us. All right, it took 1 second. All right, let's see. Hmm. So the braking distance is 61.3 and the stopping distance is, okay, the full stopping distance is equals to 96.25. We did a little bit more maths than they asked for. But anyway. Okay, here this is the measurement of reaction time for school laboratory experiment. Okay, in this experiment, you can see a person A is holding a ruler on just on top of the fingers, all right, the thumb and the index fingers, all right, in between that, person B is going to grab it. Okay, the person B is at the start of that particular ruler. Now, if we release the ruler from the person A's hand, then the person B will, at that moment when the person A releases the ruler, will switch on the timer. And at the same time, person B will grab that ruler. So it will then measure person B's reaction time. The distance traveled by the ruler between the person B's finger is equals to that the determination of how much reaction time that that particular person is having. Okay, so we can see about halfway through the ruler was caught by person B, right?
Yeah,
We can repeat this same experiment, all right, if we give the person some kind of like caffeine. Okay, let's say if we give him caffeine, all right, stimulants, then the person's reaction time will decrease. Okay,
yeah,
and if we give him something, if the person is tired, then the person's reaction time will uh, increase. Okay,
increase.
so factors that affect reaction time: the distance traveled by the car when the driver realizes they need to brake when they applies the brake. Reaction time is equals to speed of the car times the reaction time of the particular driver. Tiredness, distraction, intoxication. Okay. See, intoxication will not only be like something that is voluntary. Okay. Sometimes it can be involuntary. Explaining the reason. For example, if you have a cough syrup, okay, you were having a cough related problem or you were sneezing. Okay. So you decided that you want to have a cough syrup to get rid of it, and which
Yeah,
you can decide to have, right? You have all the rights to do that. And
yeah,
if you do that, you should be advised from your doctor that whether that particular medicine will make you sleepy or not. Okay. So if
yeah,
possible, all right, if you have taken a medicine, those that either have alcohol in it, okay, because cough syrups will have alcohol in it. Okay, those alcohols are to reduce your thickness of the cough so that you can easily get rid of them. Okay, and There will be medicines in it, those that will make you feel drowsy. Okay, because often with cold, we also get sore. Okay, we get body ache. All right.
Yeah.
Since these factors can affect the driver's reaction time, they directly affect the thinking distance. All right. So they affect the thinking distance, but does not affect the braking distance. Because once the brake is applied, if the person holds on the brake, I mean, a person cannot be that intoxicated that the person will not be holding the brake. Okay, now there are accidents of people pressing the accelerator instead of the brake, right?
Yeah.
Nervous, yes. Those ones are deadly mistake and often leads to fatalities. All right. So, three additional factors that affect the thinking distance are tiredness, distraction, intoxication. Okay. Hence, a tired driver's reaction time is greater, takes a longer time for him to react. You will often see a tired driver slipping out of lane, all right, because road goes in a curvature, right? And you will see them slipping out of lane here. And by the way, a car naturally has a tendency to go straight. Doesn't necessarily matter what's the lane. Okay. The cars,
Yeah.
their normal speed, the steering wheel by itself aligns straight. Okay. If you let it go, because it's a power steering. Okay. It
Yeah.
aligns up straight. At the same speed, a tired driver's thinking distance will be greater than a driver who is alert. Okay. So alert driver thinking distance is 12.5 meters, all right, at 20 meters per second. And a tired driver thinking distance is 20 meters at 20 meters per second. So you can see the tired driver has a significantly higher, reaction time. Factors that affect the braking distance include, so braking distance is the distance traveled by the car after the braking force has been applied, okay, whilst the car is slowing down. So what are the things that can affect it? Vehicle condition. Are the tires very poor? Are the brakes in very bad condition? Okay. Road condition. If the road is wet or icy roads, makes it harder to brake and stop. Vehicle mass. A heavy vehicle such as a lorry takes longer to stop. That's why you will see for safety issues, lorries never go at a very high speed in the street. Okay. They are all
Yeah.
bound by the speed limit, which is 80 kilometer per hour. Okay. They themselves do not have a tendency to suddenly brake, or they can't even suddenly accelerate. That's also something they can't do. Okay.
Yeah.
Yes, just the sheer mass that they carry is what is the driving force there. Meaning, if they apply brake, they need to be well aware of the reason they are applying the brake and also coming to a particular halt. Okay, because once they are stopped, also getting going, moving is also getting moving is also very, very difficult for them. Okay, when a driver applies brakes, this frictional force between brakes and the wheels of the car, the frictional force works on the brake. It transfers the energy from the car to the brakes. Therefore, the kinetic energy of the car decreases because the brakes convert it into thermal energy. And the thermal energy of the brakes increases. The brakes heat up. Braking uses significant amount of your car's fuel power, or the kinetic energy when transferred to the braking power. Okay, it takes up significant amount of energy. That's why those hybrid car or electric car, those that can actually also grab that energy from that braking of their electric motor, they can drive for longer. Okay, that's because it's a significant amount of energy that the car wastes just because of braking. That's why you will see during city driving, your car will maximum top like 10 kilometer per hour. Okay,
Yeah.
it is a very good car. All right. But then a hybrid vehicle on a city driving will go 18 kilometer per hour. That's because every time it braked, it extracted that energy. All right. The electric vehicle extracted that energy from brake and put it back in the battery. And because the efficiency of that process is quite high, So they could just go and reuse again. And also at the same time, their brakes don't wear out as much as a petrol car or a diesel car. So here,
Yeah.
braking force and speed. Okay, greater the speed of the vehicle, the greater the braking force required to bring it to hold. Because you have to understand in this way. So mass of anything, okay, times the velocity is equals to momentum. All right. Momentum is equals to mass in kgs. So our typical car can be 1600 kilograms easily. Okay. Times. All right. Let's say the car was moving at 20 meters per second. Okay. So multiplied is the momentum. If you are applying the braking force, you must overcome this momentum by that particular braking force. Okay. Since the braking force would need to be larger, the deceleration vehicle will be large as well. This is due to the link between resultant force, acceleration, and Newton's second law of motion. Large deceleration could lead to brakes overheating and loss of control of the vehicle. Because if the, all right, did you get the point? If the,
Yes, sir.
if the vehicle brakes overheat, this can lead to loss of control of the vehicle. Okay. That's
Yeah.
because, when the overheated brakes has a lesser friction between the contact surfaces, those that are producing the friction to basically stop that car. Understood?
Yeah.
Okay. A car traveling at 15 meters per second, when the driver applies brake, the car decelerates uniformly and stops. The mass of the car and the driver is 1500 kgs. Together, they make a total kinetic energy of 168,750 joules. How much work is done by the braking force to stop the car and the driver? Okay. So work done is equals to force multiplied by perpendicular distance. W is equals to Fs. Okay. Now, if the car is traveling at 15 meters per second, all right, and the car with the driver has a mass of 1500, okay, because we already have the work done value, all right, which is 168,750, and then we know the force, all right, which is 6,000 Newton, all right, the braking force of the car, 6,000 Newton, we can work out all of these values. So
Yeah.
for part A, all right, work done is the energy transferred from the car and the driver to the brakes, and the energy transfer from kinetic energy to thermal energy. In this case, the car brought to a complete stop. 168,750 joules of the energy transferred from the kinetic energy to heating up the brakes. Okay. And then we get work done is equals to force multiplied by distance traveled. So then we get the work done value. Now distance traveled, if we find it out, we will do work done divided by force, and then we divided with the 6,000. 6,000 Newton was the braking force of the car, okay? And then the car will travel a 28.1 meters. So yes, we can also calculate the same thing using the force that we are applying using this particular formula. Now, our next one, estimating the deceleration forces. Okay. The thing that is written here, HT only means higher tier. Okay. So if
Okay.
you are higher tier, all right, you didn't take foundation. So
No.
this is what you have to do. Now here, braking force multiplied by the braking distance is equals to, all right, work done. Now, also can be calculated with half times mass times velocity. Because when before braking, the car had kinetic energy, and that kinetic energy is equal to the work done, okay? After the force of braking and then the distance that it will be traveling. So we can actually use these two things to find out our any cars. So here you can see uh, at 18 meters per second, the braking distance of a typical car is 50, of mass 1500 kilogram is 24 meters. Use this information to estimate the braking force of a typical car. Now, braking force, we know that braking force is equals to times the distance is equals to, so force times distance is equals to the work done, okay, W. But W
Yeah.
equals to also the car traveling, which is half time M V square, okay? So we don't know F, we know the distance, which is 24 meters, equals to half times the mass of the car, which is 1500, times the velocity, which is 18 meters per second. And you can see how everything is just getting put together very easily. So half times 1500 is 750 times 18 divided by 24. And once we do the math, oh, the velocity will be squared, by the way.
Okay.
All right. And once we do the math, we get 10125 Newton. So the car applied a 10,125 Newton braking force. All right.
Yeah.
Which is a very big braking force actually, compared to the mass of the car and the person sitting on it. So yeah, all right. We also did a particular work done over here. Okay. Now this particular topic is fully done. Okay.
Okay.
All right. And probably anything related to this that you would have to do is fully done. All right. I just want to give you a particular recap of the formulas that you have gone through at this particular place. Okay. So
Yeah.
here, stopping distance is equals to thinking plus braking distance. Okay. So
Yeah.
let's write it down. Okay. All right. Now, reaction time can be impacted. What are the causes that can cause reaction time to be impacted? Stimulant,
Um. Yeah.
yes. It can decrease the reaction time. Number two, other things can be tiredness, right?
Yeah.
Okay. Anything else you can think of?
Uh. Distraction.
Okay, distractions. Also, distractions. Okay. Drugs. Okay. Both medicinal drugs and all the drugs, those that are used for other purposes. Okay.
Yeah.
Okay. So now factors affecting braking distance may also include conditions of brake and road. And estimating decelerating forces. Okay. Here we have to write down the formulas. The formulas is work done is equals to force times distance. So work done, force times distance. And finally, all right, work done will also be equals to, all right, kinetic energy. So which means it will be equals to half mv square. Okay. So which we can then use to estimate. We are done with this one. Okay, let's do some exercise related to this.
Okay.
Okay, so let's see. The graph in figure 1 shows how the braking distance of a car driven on a dry road changes with the car speed. Okay, draw a new line in figure 1 to show how the braking distance of the car on an icy road changes with speed. So braking distance on an icy road will be greater. Okay, this one you just write down here. Icy road equals to greater braking distance because the road conditions are not good.
Yeah.
It has nothing to do with drivers uh, thinking.
So,
Okay.
sir, if the road is wet, will the braking distance be greater than icy road or not?
No, icy road, the braking distance will be the greatest. Okay.
Okay.
Because a frozen road is very slippery. Maybe, when you were young, you played on a glide, right? Like you
Yeah.
went up and then you slide down. Those that were the most smooth, you could glide down like the fastest through those. Okay.
Yeah.
So in driving in an icy road, the challenges that are faced are when the brakes are being applied, the brakes do stop the tires, but the tires never stop. Okay, they keep on slipping through that solid surface. Okay, which is very, very,
Yeah.
all right. Now, if the ice melts and it is cold, then it is not impacted much. But if the
Yeah.
ice remains solid, then it is greatly impacted. Okay, so now the speed icy road is equals to greater braking distance. All right. So greater braking distance will be in a lower speed. Okay. So braking distance in meter will increase. Just remember that just whatever you draw a line, it has to be to the left of the original line.
Okay.
Okay? Whatever you draw the line, you have to draw to the left of the line because I said out the distance will be greater. Meaning before at 22, your distance was 36. Okay? At 22 meters per second, your distance was 36 meters. Okay? Now at 19, you are representing 40 meters. Okay? This much is enough. All right?
Yeah.
This much is enough to show that at lower speed also, you have a greater braking distance and should be enough to give the answer correct. Next. Hmm. Student A says that the braking distance can also increase if the driver is intoxicated. Student B says braking distance can also increase if the driver has a worn out tires. Which student is correct? Give a reason for your answer. I think you can give it a try. Just think of braking distance, not thinking distance, okay?
Uh, I think student B.
Student B is correct. Okay. Student B correct, you will get 1 mark. Can you give the reasoning?
Because they're asking for the braking distance,
Hmm.
and the condition of the tires can affect the braking distance, as worn out tires, I think, will be less effective.
Okay. So we can write in these two ways. All right. First of all, let's make this one. Okay, student B is correct. All right, this part gives us 1 mark. The second one, the one that you want to write, has to have a keyword writing. Okay, so how do you write it? The braking distance depend on road condition or the vehicle condition. Okay, the braking distance depends on the vehicle condition and road condition. Okay, so this is what you wanted to write, but you went in like in a writing like a lot of how to say that a lot of description to be explaining this, but your
Oh,
goal
it's
is the same
two
thing.
marks.
Hmm. Your goal is to explain the same thing, but you are using like many wording to explain the same thing.
Yeah.
So you would have to take a pause on that. All right, and only answer with keywords. Now that you have understood the braking distance depends on vehicle condition and road condition, if I were to ask you about the thinking distance, could you not think of like this? The thinking distance depends on the driver's, all right, alertness,
Yeah.
all right, the driver's alertness, all right. Did you get the point?
Yeah.
Mm, good. So the graphs in figure 1 shows how the velocity of two cars, A and B, change from the moment the car driver seen an obstacle blocking the road. Okay. So we can see two drivers. One driver has traveled further. Okay. After they saw at time 0, by the way, both of them.
Yeah.
All right. They can be in two different time, by the way. It doesn't matter. All right. It's
Yeah.
that when they saw it, it's 0. Okay, for both of them. One braked too early, one braked quite late, right?
Yeah.
Using figure 1, state and explain which car had a smaller stopping distance. Okay, I think this is state and explain. So you just have to say which one, okay, has a smaller, and then explain that why did you choose that particular one. You don't have to do calculations. Okay.
Yeah.
So which one? Car A
Uh,
or
s- so car A has a small stopping distance because the thinking distance plus the what's that braking distance is lesser than car B.
okay. So first of all, I will both of your answers are correct. Just the second point requires a brushing up of the answer. Okay. So
Okay.
car A, all right, has a smaller stopping distance. Okay, that is your conclusion, and that conclusion is correct. That is equals to 1 mark. Now, the reasoning behind you want to give was that overall this car stopped very early, right? In
Oh, yeah.
in the first instance, you could have just this would always be reasonable if you just say the way you wanted to say, you can just word it in this way. The car starts to decelerate quicker because both are decelerating at more or less the average constant manner. Okay, the deceleration.
Yeah.
Okay, it is taking the same amount of time, but the car A starts to decelerate quicker. So this guy would have traveled a little bit more than above the comfort zone, isn't it? Okay.
Yeah.
Yes. So we would say the car A starts to decelerate quicker. All right. Okay.
Yeah.
All right. So this is done. Okay. Now here, one of the car driver was on the phone. The other driver is wide awake and alert. Determine which driver drove which car.
So
Yeah.
car A is the awake and alert one, and car B is the phone.
Because,
Because the first one braked earlier than the second one.
okay. All right. Your answer is correct. All right. Your answer is correct. Just we can say the driver in car A. I think this one no need to write. You have done it quite.
Okay.
So just skip on this one. Here, next one. A different driver in car C has a stopping distance of 15 meter and thinking distance of 4 meter. Calculate the braking distance of the driver in car C. So stopping distance.
Stopping distance is thinking plus braking.
Mm-hmm.
So braking is stopping minus thinking.
Okay.
So it's 15 meters. Sorry, 11 meters.
11 meters. Yes. Yeah, but this is something you really need to understand. How do we get 3 marks in such a question? First of all,
Uh,
write down the formula, just like the way you said. Okay. But I
yeah.
am I'm very sure, even though you will say it, you will get in the confusion of writing it. So I'm just taking that away. Okay. Write it because it has more marks. Where will the teacher
Yeah.
mark if we are not giving him the points? I mean, we know. Let's say we show him that we know, and we'll just show him in the paper. All right.
Okay.
Yes. Often this is common problem. Year 10 students don't train on writing like how the mark scheme wants. Okay. And then they will get into this particular issue later on, is that they're writing correct answers. No problem. I had this problem with a student a few days back. Uh, he's a brilliant student. All right. No problem at all.
Yeah.
All he got caught in every answers, 1 mark, 2 mark, every answers got deducted. And in that way, he got deducted in 13 questions, 13 marks. How? Keywords. Keywords. The teacher wrote that this keyword is missing. This keyword is missing. Even though he explained the same material, but the teacher is like, since I didn't receive the keyword, I am unable to give marks in here. Okay.
Yeah.
So the same thing also applies to you. Okay. All the GCSE curriculum, all right, will be my pencil is not writing for some reason. Just a moment. Let me check if I can fix it.
Okay, sir.
I mean, it usually stops writing if it doesn't have charge. But now what happened is it got disconnected from the Bluetooth for some reason. Okay, so braking distance will be equals to stopping distance minus thinking distance. Okay. So usually in these cases, I need a restart of the tablet. Okay. So braking distance is equals to
Yes.
stopping distance minus thinking distance. When you write that, you will get your second mark. And then you will calculate the braking distance. 15 minus 4 is equals to 11 meter. That's how
Okay, sir.
on a lame question like this, you would get your 3 marks. Because you are asked something and you gave that answer according to the points it needed to be mentioned. Okay. And
Yeah.
always you will get your full marks in that way. Avoid any steps, you will not get it. Okay. Now you'll be,
Yeah.
how will I know where to do a shortcut and where not to do? Let's say if a particular math involves 10 steps and the mark is given 3, yeah, you can skip on any one of the steps. They are not key steps. None of them will be considered key steps. It's okay. You can like skip somewhere, wherever possible, and then make it a
Yeah.
shorter because you have many places to give the marks on. Okay. But if the question is like this one, where it was literally like where to even put that point, right? This is such an easy question to ask and asked by 3 marks. This is direct exam board questions, by the way. AQA question, paper question, these are. All right.
Yeah.
And if they give you 3 marks like that, you won't be able to deal with it. So how would you do it? Only way would be write logically. All right. What are the points can I include so that I give the teacher best possible chance to give me mark? There is an alteration of a formula. Let me put it there. Even if that particular formula mentioned by the formula book or not, that doesn't matter. If you mention it, you will get your mark. Because after all, the marking is dependent on the teacher who is actually doing the marking physically. Okay. The mark scheme may suggest 10 things, but very seldom many students will just like write like mark scheme, by the way. Those that do does get the benefit of it. They will get the mark. Okay. You just made the life of the teacher so easy. So they'll give you the number. All right. Because after all, they don't even know you. What's the enmity with you, right?
Yeah.
Yeah. So I'll end the lesson here. All right. Even though it's a bit
Okay.
early, I'll have a lesson tomorrow scheduled. I'll try. Okay. If that is
Okay.
not possible, I will give the timing though, but check if it is okay with all of you and then join the lesson. All right. Okay.
Okay, so I'll check if I'm free tomorrow.
Yes, if it is not possible by you, because maybe you guys already did a lesson on the the afternoon time, which is okay.
Yeah.
The tuition center that I go, the afternoon time that I will get available might not be I might not have a classroom available, so I might not offer that time. Okay, that
Yeah.
depends. All right, but it's okay. Let's check on that one first. Otherwise, when the holiday starts, I'll take another extra lesson. All right. So
Okay,
take
sir.
care. See you in the next lesson. Bye.
Bye, sir.